Going live. 1 minute.
Hello children, welcome to Teachtigers, and this is Vamshi, your chemistry mentor. So children, welcome to this fast track revision program of chemistry. Now this program is all about how to score 70 marks in your JEE examination, right? Not only that, I guess you people are very much aware that your board exams have been postponed till May. So if you do attend my classes, I assure you this would be helpful not only for your mains, it would be helpful even for your board examinations. And people who are preparing for NEET exam, I assure you, you can also watch this program, it would be helpful for you. So children, we are going to run this program till the 16th of February. This fast track program will be running till the 16th of February. We will have live classes, and along with this, we will have assignments on a regular basis on each topic that we are covering. We have designed the program such that you follow our classes, you would be securing 70 marks in your JEE. So please do watch and subscribe our channel. And if you people have any doubts, any queries regarding this subject, in the description box, we have our channel Telegram ID. Please post your queries on the ID. We will be helping you. Our team will reach you within no time. Right? So hope you people will enjoy this session with me. So let's begin our session. We are going to start with the most important topic of your grade 12 of your chemistry part, and that's aldehydes and ketones. Now guys, you will definitely have a question based on this in your JEE, right? So let's begin this topic with this interesting Aldol condensation reaction, right? So what's this reaction all about? What is Aldol condensation? Can you people see this reaction contains aldol. Ol is an alcohol, and you people have even an aldehyde, and it's a condensed product. So what's this aldol condensation reaction? What kind of carbonyl compounds give this reaction? Fine. So let's see aldol condensation reaction. Right, see, aldol condensation reaction is given by carbonyl compounds. All aldehydes and ketones that do have at least one alpha hydrogen. So the condition for this reaction is that any aldehydes or ketone which do have an alpha hydrogen, at least one alpha hydrogen, they react in the presence of an alkali, say NaOH, or sodium carbonate or barium hydroxide. In the presence of an alkali, right, they react to give beta hydroxyaldehyde. The product of this reaction is beta hydroxyaldehyde, and that's the reason we call it as aldol, because it contains aldehyde group and alcohol group. And I told you this reaction can be even given by ketones having alpha hydrogen. If ketones react, then the product contains both ketone and hydroxy group. Therefore, we call it as ketone. But generally, this reaction is referred as aldol reaction. Right? So first, we'll see what is aldol reaction. Then we'll see the condensed product of aldol reaction. Is that clear? So let's see. What is this? How do aldehydes and ketones having alpha hydrogen react to give beta hydroxyaldehyde or ketone? Now, as I said, this reaction is given by only compounds having alpha hydrogen. Now, why is this reaction? This reaction is due to the acidic nature of alpha hydrogen. But the question is, what do you mean by alpha hydrogen? What does alpha hydrogen mean? Guys, this is this hydrogen that is bonded to alpha carbon. We call it as alpha hydrogen. Now this is the carbonyl group and this is the sp3 hybridized carbon that is directly attached to this carbonyl group. We call this carbon as alpha hydrogen and the hydrogen as alpha hydrogen. So guys, all aldehydes and ketones that have at least one alpha hydrogen, this presence is important, is required. So such aldehydes and ketones which have this alpha hydrogen, they react in the presence of an alkali to give beta hydroxy aldehyde or beta hydroxy ketone. We call that product as aldol or ketone, right? For example, I give you a few options here. Can you please check it out which of them are going to give you aldol reaction? The first one is benzaldehyde. Can you people guess whether this compound can give aldol reaction? Yes or no? Now can you see this is the carbon that is attached to carbonyl group and it does not contain any alpha hydrogen. The valency of carbon is 4. Can you see this does not have any alpha? So this is not going to give you aldol condensation reaction, right? Though it can participate in cross aldol. I'll tell you what does that mean in the next slide. Now guys, this is our sp3 hybridized carbon which is directly attached to the carbonyl group. So this is our alpha carbon and it has got 3 alpha hydrogen. Hence this is capable of undergoing aldol reaction. Now this has got 2 alpha carbons and 6 alpha hydrogens. So this is also capable of giving aldol reaction. Now the last one is propanol which has got 1 alpha hydrogen and 2 alpha hydrogen. Therefore, all these compounds, acetophenone and acetone and propanol, all these are capable of undergoing aldol reaction because they have alpha hydrogen. Right? Now let us see the reason for this reaction. Guys, this reaction is because of the acidity of alpha hydrogens. What do you mean by acidity? Now hydrogens which are capable of getting released as H plus, we call them as acidic hydrogen. So the alpha hydrogen of the carbonyl compound is acidic in nature. But why? What's the reason? Guys, the acidity of alpha hydrogen is because of 2 reasons. First, the conjugate base that is formed by the removal of alpha hydrogen is stabilized by minus I effect of electron withdrawing ability of carbonyl group. Now guys, I guess you people know the ability of a substance to act as an acid depends upon the stability of its conjugate base. Greater the stability of the conjugate base, greater is its ability to act as an acid, right? Here the conjugate base will get stabilized by the carbonyl group C double bond O, and in fact the anion, the conjugate base, is even resonance stabilized. Let's see how. So this is our alpha hydrogen. Can you people see? Now that is the alpha hydrogen. I said this alpha hydrogen is acidic, and this is the reason. This is the condition for a compound to undergo aldol reaction. Now, as I told you, this reaction is carried out in the presence of base. So I have taken a base. What's a base? A base is a substance that abstracts a proton, which has an ability to grab a proton. So this base grabs the proton. This hydrogen is released as H plus. When you remove this, can you see this? Fine. So this base donates the electrons to hydrogen and releases this hydrogen as H plus. Now, can you see this hydrogen donates electron to carbon and you are going to get this anion, right? So this is the conjugate base that is formed by the removal of this acidic hydrogen. Now, is this base, conjugate base, stabilized? The answer is yes. Why? Because this negative charge on the carbon is stabilized by the minus electron withdrawing ability of carbonyl group. I guess you people know carbonyl group is a strong electron withdrawing group. because of the partial positive charge on the carbon, this acts as an electron withdrawing group. Moreover, can you see that this, anion conjugate base is also resonance stabilized? These are the pi electrons, this is single bond and this is negative charge. So how does the delocalization takes place? This carbon gives electron to this carbon and this in fact gives this. So you are going to get this. Do you people see that there is a double bond here? We call this as ene and a hydrogen removed from alcohol, enolate ion. So children, the conjugate base that is formed by the release of alpha hydrogen of the carbonyl compounds is called as an enolate ion. Right? So the species carbonyl compounds that undergo aldol condensation reaction first do form enolate ion, which is the conjugate base by the removal of the alpha hydrogen. Right? So let me revise, guys. Aldol condensation reaction is given by carbonyl compounds having alpha hydrogen. This alpha hydrogen is acidic in nature, right? And this reaction is carried out in the presence of a base. A base abstracts a proton, you will be getting a conjugate base, which is stabilized by the -I effect, electron withdrawing ability of the carbonyl group, as well as the resonance stabilization of the, this negative charge. We call this conjugate base as enolate ion. Right? So guys, let us see further how this reaction takes place further. Guys, the first step is the formation of enolate ion, and this reaction is a nucleophilic substitution reaction. I guess you people know characteristic property of carbonyl compounds is that they do undergo nucleophilic substitution reaction, right? Because the carbonyl group has got partial positive carbon and hence it loves to attract negatively charged species. That's the reason they undergo nucleophilic, not substitution, guys. This is a nucleophilic addition reaction. I'm very sorry, right? This is a nucleophile. Why nucleophile? Because the carbon of the carbonyl group is positively charged and it likes the nucleophile, negative charged species. Right? So the question is, the carbonyl compound is capable of undergoing nucleophilic attack. But what's the nucleophile here? Guys, if you people see, the nucleophile here, this is an addition reaction, right? This is a nucleophilic addition reaction. Guys, this nucleophile in this reaction is enolate ion. So the first step is the formation of enolate ion, which acts as the nucleophile and it does attack another carbonyl group. So let's see this example. Guys, I have taken an ethanol, right? So in the presence of this, you are going to get beta hydroxy. This is our alpha carbon and this is the beta carbon, right? So this compound is called beta hydroxy aldehyde. Why is this beta? Because this carbon which is attached to carbonyl group is called alpha. This is beta. We call this as beta hydroxy aldehyde, which on heating, the further step is the condensed product. To give you alpha beta unsaturated, there is a double bond formed between alpha and beta carbon. Why and how is this product? Let us see the mechanism of this reaction. Guys, let's see the first step. We have this aldehyde, acetaldehyde. Does this have an alpha hydrogen? Yes, this is our alpha carbon and this is the alpha hydrogen. So this is capable of undergoing Aldol reaction. Now I'll take a base here. You can add NaOH, calcium hydroxide, any base you can add. What does this do? This abstracts this alpha hydrogen as a proton and you are going to get its conjugate base. Just see, this is our conjugate base. So this conjugate base is stabilized by electron withdrawing of this C double bond O carbonyl group, as well as there is a resonance here. Can you see? Fine. So this is the resonance stabilization. I have a doubt here. Can you tell me which among them is more stable? Can you people see, as a result of resonance, there is a negative charge on oxygen here. And I guess you people know, negative charge on the most electronegative element is more stable. So this structure is in fact more stable than this. Right? So the first step in Aldol reaction is the formation of enolate ion, which is formed by the removal of alpha hydrogen. Now let's see the second step, guys. This is what we have. This enolate ion, I told you, is going to act as a nucleophile. This is going to act as a nucleophile. And as I told you, the carbonyl carbon has positive charge and it loves nucleophile. So what's happening here? This nucleophile is going to attack this carbon, but the valency of carbon is already filled. It's 1, 2, 3, 4. How does it allow the nucleophile to attack this? Now, if you people remember here, I was telling you that the negative charge on oxygen is stable. So, oxygen doesn't act as a nucleophile because it loves to keep negative charge. Carbon is not so happy with the negative charge. Therefore, it tries to donate the electron. Negative charge on carbon atom are strong electrophiles. So they disperse their electron cloud and hence it donates its electron to carbon. Now how does this carbon avoid this nucleophile? It has already 4 bonds. So guys, this is going to break its pi bond between carbon and oxygen. It breaks this pi bond to oxygen. So this oxygen gets negative charge and this carbon gets positive charge and hence it invites this carbon enolate ion to attack it. So just see what's happening here. So this is our carbon of this. It has donated one electron. Oxygen has got the negative charge. This carbon would get positive charge, and now this gets attacked by this aldehyde. Can you see there is carbonyl group here and alkoxide ion formed here. Right? So it's basically a dimerization reaction. The first step is dimerization. Now as long as there are the alpha hydrogens in the product, this keeps on reacting with the other species. Till time all the hydrogens are removed, the aldol reaction keeps on continuing. So the first step was formation of enolate ion. Second step is the nucleophilic attack on the carbonyl carbon. Let's see the third step now. Guys, this alkoxide ion form, right? I guess you people know alkoxide ion is a strong base and hence it reacts with water. How water, I guess you people know that we have carried this reaction in the presence of a base alkali. So you have aqueous water there and the first product formed was alkoxide ion along with water. So this O minus grabs this proton, active hydrogen of water. I guess you people know that the hydrogen of water has got partial positive charge. So this O minus grabs the proton and is going to become an alkoxide ion, grabs the proton and becomes OH. So guys, this is the third step. First step, formation of enolate ion. Second step, nucleophilic attack of enolate ion on the carbonyl carbon. Third step is the formation of aldol. Right? How is that formed? This is formed where the alkoxide ion reacts with water to form this. So can you see all this reaction is basically acid-base reaction. First step, base grabs a proton, it's an acid-base reaction. Second step, nucleophilic attack. Third step, again O minus grabbing a proton. Most of the organic reactions, I guess you people know, they are all acid-base reaction. Even in the second step, which is a nucleophilic attack, the carbon which has negative charge is donating an electron. So that is acting as a Lewis base. An electron pair donor is called a Lewis base, I guess you people know. So all the 3 steps were acid-base reaction. Now if you see the product of this reaction, this is our carbonyl carbon, this is alpha, this is beta. So the product of this reaction is beta hydroxy butyraldehyde or 3-hydroxy 1, 2, 3, 4 butanal, right? So guys, this is the aldol reaction of acetaldehyde. Now can you see if the number of carbon atoms have been doubled, because I said it's a dimerization reaction. In fact, this can further undergo Aldol reaction because there are still 2 more alpha hydrogens. So by the way, can you see that there is the OH group present on beta carbon? That's the first point. Second point, you have a new bond between carbonyl carbon and alpha carbon. I'm sorry. If you can see here, this was the carbonyl carbon. This was the carbonyl carbon and this was our alpha carbon. So remember, in case of an Aldol reaction, there is a new bond formed between carbonyl carbon and alpha carbon. So alpha carbon gets converted into OH and this is the alpha carbon. Is that point clear? Fine. Now guys, just see the next point. Till now we have just discussed about Aldol reaction. Now next let us see what is Aldol condensation. Now the product of Aldol reaction, that is beta hydroxy aldehyde or beta hydroxy ketone, they do readily lose water just by heating or in the presence of an acid or in the presence of a base. They readily lose water molecule to form alpha beta unsaturated aldehyde or ketone. For example, let's see this case. This was our beta hydroxyaldehyde. Just heat it. You have a bond. Water gets eliminated. OH from beta carbon and H from alpha. Remember, the pi bond is always formed between alpha and beta carbon. But sir, why? Why not between OH and beta and gamma? No. What's the reason? Just see guys. This pi bond that is formed is in conjugation with this pi electron. So there is a resonance stabilization of this pi bond. So that's the reason beta hydroxyaldehyde, they readily lose water molecule forming alpha beta unsaturated aldehyde or ketone. Right? So the product of Aldol condensation reaction is alpha beta unsaturated aldehyde. Right? So this is about Aldol condensation reaction. Let's see some examples here. Let me take propanone. Right? This is the enolate that is formed CH3 C double bond OCH2 minus. Now this attacks this carbon. So guys, just see the number of carbon will be double 1, 2, 3, 4, 5, 6. This is our carbonyl group. This is alpha carbon beta hydroxy. If you heat it, the product fine. If you heat this, you are going to get, this is our alpha, this is beta. Alpha beta unsaturated aldehyde will be getting. You see, just see. Right? This is our alpha beta. There is a double bond between this. Now what's the impact name? 1, 2, 3, 4, 4 methyl pent 3 2-ol. We also call this as mesitile oxide. Fine. So children, this is the Aldol condensation product. As I told you, the first thing that there will be OH on the beta carbon and new bond is formed between alpha carbon. These are alpha carbon and this is the carbonyl carbon of the earlier molecule which is getting converted into OH. And of course, the final product would be alpha beta unsaturated aldehyde. Now I just want to go through the reverse order. What's that? Suppose if they ask you what is the carbonyl compound that undergoes Aldol condensation to give this product. Suppose they have given this and they have asked you retrosynthesis, we call this. That means they give the product and ask you what is the reactant. How do you do? Since this is alpha beta unsaturated, which is obtained by heating beta hydroxy. So first identify whether this is alpha beta. Yes. Add OH to the beta carbon and H to the alpha carbon. That's what I have done. Just see, OH to the beta carbon and H to the alpha carbon. I have got this. And I told you in Aldol condensation reaction there is a new bond formed between alpha carbon and carbonyl carbon. Right? So this carbonyl carbon which is forming OH would be CH3 C double bond OCH3. Am I right? And this will be the alpha carbon which you can know by adding one alpha. So both these are same. Am I right? So retrosynthesis questions are also asked in the main. They give you the product and ask you to write the reactant. Is that point clear? Now let's see what is crossed aldol. What do you mean by cross aldol? So this is the aldol condensation reaction carried out between two different aldehydes or between different ketones. Let's see, this reaction is carried out between two different aldehydes or between two different ketones. We call this reaction as cross aldol. The earlier reactions were simple aldol. It is carried out between two, same molecules. Here we have different aldehyde. For example, let us see this case, the first case. If you select two carbonyl compounds having alpha hydrogen, what do you mean by that? So I told you this reaction is between two different kind of aldehyde. Suppose this aldehyde contains alpha hydrogen, even this carbonyl compound aldehyde contains alpha hydrogen, then we are going to get a mixture of four products. All beta hydroxy aldehyde, all beta hydroxy ketone. For example, let us consider this case, the crossed aldol condensation reaction between acetaldehyde and propanol. So they are different aldehydes. Now in this case, we are going to get a mixture of four different species, and it's very difficult to separate. So synthetically, this reaction is not so important because you are going to get a mixture of four species, very difficult to separate them. Then what are important cross aldol? Let us see later. First, let us see how are we going to get four different species. Out of these four, two would be simple aldol and two would be mixed aldehyde. So first step, as I told you, this reaction is carried out in the presence of an alkali. Then the beta hydroxy aldehyde form on heating would give you alpha beta unsaturated. Fine. Anyways, let us see what's the first step I told you. The first step in aldol reaction is the formation of an enolate ion. Let us check it out. The first enolate ion. When I treat this mixture with a base, it removes an alpha hydrogen. We have two different species of alpha hydrogen here. This is one alpha hydrogen, even this is alpha hydrogen. So you are going to get two sets of enolate ion. Let us see the first case. This is the enolate ion formed by the removal of alpha hydrogen from acetaldehyde. So what does this do? I told you aldol reaction is a nucleophilic substitution. This acts as a nucleophile and attacks another carbonyl carbon. Now can you see there are two carbonyl groups which are ready for the nucleophilic attack. So you are going to get two species here, two aldol product. Just see. This enolate ion of acetaldehyde can attack another acetaldehyde. So this goes and attacks this. This gives electron. This was very simple, like our simple aldol product of acetaldehyde. This we have already done. But the second thing is, can you see that this enolate ion can even attack this propanol? Because this is also capable of undergoing nucleophilic attack. So this when attacks, you are going to get simple aldol product. But when this enolate ion of acetaldehyde attacks propanaldehyde, you are going to get a cross aldol product. So let us see what's that we have got. I have got HC double bond O. This CH2 going to attack this O minus, which will react with water to get this. So CO, and this is what we have. So can you see, this is our carbonyl carbon, this is alpha, beta, beta hydroxy, you have 4 carbons. Now what is the other case? This carbonyl group can attack here. So what is that you are going to get? CH3, CH2, CO minus, which reacts with water to give us. So children, you even have the same here. Please check it out. You have 1, 2, alpha, beta hydroxy aldehyde. The number of carbon here will be 5. Because it's a dimerization reaction which is carried out between propionaldehyde and acetaldehyde. Propionaldehyde has 3 and this is acetaldehyde having 2. So you are going to have a total of 5 carbons. So this is also a beta hydroxy. This is also a beta hydroxy. The first species is the simple aldol product. The second is cross aldol. But I told you, you are going to get a mixture of 4. These are the 2. What about the remaining 2? Now I told you, even this can form an enolate ion. So the first enolate ion was from acetaldehyde. Now the second enolate ion is from propionaldehyde. So identify the alpha carbon. This is our alpha carbon and this is the alpha hydrogen. So this is what I have done. First I have removed one hydrogen here. So you have got this enoletane, right? So now this can attack like your acetaldehyde, which is a different aldehyde. So you are going to get a crossed aldol. What's that you are going to get? This is CH3, CH. You also have a C double bond OH. I am writing this here. So this goes and attacks this CO minus, which becomes this. So can you see there is a new bond formed between alpha carbon, this is our alpha carbon, and this is carbonyl carbon. So this is helpful for you in retrosynthesis. What do you mean by that? How do you get back the reactant from the product? Right? Now this is what we have. But this is a crossed aldol, but this enoletane can in fact attack this, propionaldehyde itself. In that case, we call them as a simple aldol product. Am I right? So what's going to happen here? This C minus would come and attack this carbon. You will be getting CH3, CH2, CO minus, which attacks with water to give OH, and this is CH, C double bond OH, CH3. You must remember that the product is always beta hydroxy. Please do check it. This is carbonyl group, this is alpha carbon, this is beta carbon. So you have got beta hydroxy aldehyde. This is a simple product. This is crossed aldol. So guys, just see, we have got a mixture of 4 different species. When you have got aldol reaction between 2 different, you have got 4 different species. Just check it out. This is simple aldol product, as I told you, and the remaining 2 are crossed aldol product, right? So 2-methyl-butanol, pen-2-enol are in fact crossed aldol, right? So these are the 4 products. This is not synthetically sold, but just see, what if we take carbonyl compounds that do not have alpha hydrogen? Say I have taken formaldehyde, or I have taken benzaldehyde, or I have taken benzophenone. These compounds can undergo nucleophilic attack, but they do not have alpha. They cannot form enoletane. Such reactions carried out between formaldehyde or benzaldehyde or benzophenone and another aldehyde containing alpha hydrogen. Now this can be synthetically important because they do not form enolate ion. So such compounds, they do not undergo, but they can undergo nucleophilic attack. So you see, what is that we have taken here? I have taken formaldehyde. This does not have an alpha hydrogen and cannot form enolate ion, but the thing is, it can undergo nucleophilic attack by the enoletane formed by acetaldehyde. So children, just see what's the enoletane here. The enoletane is CH2CHO, which is going to attack this. This is what we are going to have. Okay, so this is HCO minus, which attacks with water to give OH, and this is what we have. So guys, this is our carbonyl group, this is alpha, this is beta. So we have got beta hydroxy aldehyde, 3-hydroxy propanyl aldehyde, propionaldehyde, right? So guys, this is a reaction where a crossed aldol condensation reaction is carried out between 2 different species, out of which only one has got alpha hydrogen and the other does not have. One such reaction is formaldehyde. We can go for even benzaldehyde, right? Can you please predict what is the product? The first step is the formation of enoletane, which reacts with this. So you are going to get this OH, and this is our product. Even here you have got, right? This is OH and beta hydroxy aldehyde. When you heat this, can you see that this is going to give CH double bond CH, C double bond OH. Now you have here a conjugation even with the benzene ring also, pi single bond pi single bond pi. So this is a stable product here, right? So such compounds like benzophenone, benzaldehyde, formaldehyde, they do not contain alpha hydrogen. They cannot form enolate, but they can undergo crossed aldol reaction, right? So this is what we have here. Guys, I've just discussed about aldehydes, but in fact ketones can also be used as one of the components in the crossed aldehyde. So now can you see this is going to form an enolate, right? Now see the temperature there, I've just used 293, right? The reaction is carried out at room temperature. You need not heat this, right? So the enolate is this, right? Which attacks this. So you would be getting pH, this group, O minus, which combines with water, and you would be getting this. Can you see that this is a beta hydroxy? This is alpha, this is beta. When you heat this, it readily forms alpha beta unsaturated aldehyde. Right? So guys, this is the cross aldol reaction between two different species. I have taken here a ketone which can even participate in the mixed aldol condensation reaction, right? So guys, this is the product, first product form, right? Aldol, and then on heating you have got this, right? Now here you see pi, single bond pi, single bond pi, pi, single bond pi. So there is a continuous conjugation here. This is what's the name of this? You see, this is 1, 3. This is probe. 3 carbons are there in this straight chain. Probe, this is first carbon, this is 2, probe 2 E in one pole, and you have phenyl groups attached on the first and third, right? We also call this as benzyl acetophenone. This is the major product. Sir, what do you mean by major product? Do you have any other product? Of course, yes. The enolate formed by acetophenone can attack another acetophenone. So that would be giving you a simple aldol. But this was found to be the major product. Sir, why? Because benzaldehyde is more reactive than acetophenone. Right? So the enolate would prefer to attack benzaldehyde rather than benzophenone. Right? Hence, this is the major product. Right? Now guys, we have one more reaction which is very important in your JEE exam, and that is intramolecular aldol reaction. What's this intramolecular? You might have observed about intramolecular hydrogen bonding. Any reaction which takes place within the molecule, we call it as intramolecular aldol condensation reaction. Guys, intramolecular means within the molecule. So intramolecular reaction is internal within the molecule, internal aldol reaction. So what's this? Intramolecular aldol condensation reaction is reaction between two aldehyde groups or ketone groups that are present in the same molecule. If you do have two aldehyde groups, two ketone groups which are present in the same molecule, then that reaction is called intra in the sense internal aldol reaction. Just see guys, what is this reaction? The concept mechanism is very much same. It is due to the acidic nature of alpha hydrogen. The alpha hydrogen is removed in the first step, forming enolate, which is resonance stabilized and even stabilized by the electron withdrawing group. So crossed intramolecular aldol condensation reaction, even it also requires an alpha hydrogen. The mechanism is going to be same. You are going to get a beta hydroxy aldehyde. But what is the difference between simple aldol and this intramolecular? Let's check it out. Guys, what are the conditions? How do you know whether the product is capable of undergoing intramolecular aldol reaction? Guys, first of all, if you they give you to write the product reactant of a particular product of the reaction, check if the product is beta hydroxy aldehyde, right? Then it is definitely aldol condensation reaction. It can be either a simple aldol or crossed aldol or intermolecular. The bottom line is you will have a beta hydroxy aldehyde or a beta hydroxy ketone in case of aldol condensation reaction. So let us check what is the condition for intramolecular aldol. The first condition is that any molecule which has got two sets of carbonyl functionalities. Any molecule which has got two carbonyl functionalities in it, and such compounds are capable of undergoing aldol condensation reaction through an intramolecular phenomenon. So you need to have two different set of alpha hydrogens belonging to two different carbonyl functionalities. Let us have a look at this. This is the compound, guys. Can you please tell me what is the name of this? It is 1, 2, 3, 4, 5 pent, 1, 2, 3, 4 oxopent, pentanal, 1, 2, 3, 4, 5 pentanal, right, 4 oxo. Now can you see, can you identify, you have two, carbonyl functionalities in this compound, and hence it is capable of undergoing, intramolecular, and so this is meeting the first requirement. Now the thing is very similar. What's the mechanism? I told you it's saying the mechanism of intramolecular also involves the formation of enolatan, which attacks the other carbonyl functionality, resulting in a ring-shaped molecule. But the point here is, you ought to check out this key enolate intermediate. Now what you have, I told you, you have two different carbonyl functionalities. That means you have two different set of carbonyl, alpha hydrogens, and you are going to get two sets of enolatan. But here, this is to, guess what is the key enolate intermediate. Only then you will get the correct product. Otherwise, you will end up getting a minor product. But sir, how to select this enolatan? Let us see this. Let us see the first step. What is the first step? I told you the mechanism is same. It is the abstraction of alpha hydrogen by the base to form the enolatan. But we have a problem here. Sir, what problem? Now let us see what are different enolates and that are possible here. Can I consider this as the alpha carbon? It has got two alpha hydrogens. So you are going to have this as an enolatan. Am I right? This is an enolatan that is formed. Right? Can I remove this hydrogen? Yes. So you have this as an enolatan. You have this as an enolatan. In fact, you can also have an enolatan from this carbon. So you have got the three sets of enolatan. But how do we identify the key enolatan? That's what I spoke about this point here. The mechanism of this intramolecular hydrogen reaction involves formation of the key enolatan. But here in this step, I have got three enolatans there. Can you see this? This was the first, this is the second, and this is the third. I have got three set of enolatan. How to identify the key enolatan? Now guys, please remember these 2 points. But things to remember. While you are selecting the key enolatan in an intramolecular condensation reaction, you need to, remember 2 points. What is the first thing? Guys, select an enolatan and see that aldehydes are always more reactive because, in case of ketone, there is more plus I group, more, what steric hindrance. Aldehydes do not have much steric hindrance. So, remember, aldehydes are more reactive than ketones. Second, I told you the enolatan form is going to attack the other carbonyl functionality, resulting in a ring. I guess you are very much familiar that in the nature, the compounds with 5 and 6 membered ring are generally preferred. They are quite stable than 4 membered ring, 7 membered ring. They are unstable. You guess you people know for many reasons. Carbonyl compounds with compounds with 5 and 6 membered ring are found to be stable. If you remember these 2 points, I guess you can easily select the enolatan. Just see now what did I do? I am considering this. Sir, why did you take this? Why not this? Guys, if you take this as an enolatan, it would be attacking a ketone. I don't like it. Sir, why? Because I said aldehyde is going to be more reactive than this. Then sir, why didn't you make this as an enolatan and attack this? In such a case, I am going to get a 3-membered ring which is quite unstable. Then what? If you remove the hydrogen from here, now if you select this as an enolatan, This is going to attack this aldehyde, which is quite more reactive than this ketone. First point. Second point, can you see, it is going to form 1, 2, 3, 4, 5 membered ring. I told you 5 and 6 membered rings are usually preferred. So guys, see what's the next step here. This was the first step. Second step is same. The nucleophilic attack of enolate on the other keto group resulting in a ring. So guys, just see this enolate is now going to attack this aldehyde. Sir, why aldehyde? Because they are more reactive than ketones, and this donates 1 electron to oxygen. So guys, this is what you are going to have. Sir, how did you write this? It is always advisable to number or letter the carbon so that it becomes quite easier for you to understand. This was R1, which is going to undergo the nucleophilic attack. This is 2, 3, 4, 5. So just write a 5-membered ring. Select this as first carbon, which is going to form O minus. Right? This is first. And the next carbon is 5 because it is formed by the attack of the 5th carbon on the first. So you have a bond between 5 and 1. This is 4, 3, 2, 1. Am I right? And there is a C double bond O on 4th. So just see, this is so simple. That's how I have written. So this is what I have got. So this is our first, which is going to form O minus. This is 5th. This is 4. This is 3. This is 2. This is 1. Right? Always number it, especially in intramolecular process. It is always advisable that you people number the carbon chain. Right? And the next step, you will be reacting with water. O minus react with water to give this. Alright, so this is our carbonyl group, this is alpha and this is beta, beta hydroxy cyclopentanone. The product, whether it is simple or crossed or mixed or anything, you are going to get a beta hydroxy that you people have to remember. And what next? What next? What is the product of intramolecular condensation reaction? The product of intramolecular condensation reaction is cyclized. Because I told you, you are going to get a ring. The product will be cyclized alpha beta unsaturated aldehyde or a ketone. So guys, this was our beta hydroxyaldehyde. I just heat it. You are going to get a beta alpha beta cyclized alpha beta unsaturated ketone. So this is our 1, 2, 3, 4, 5. 2 gamma 3. So pent 2 enone. Right? So this is the product of the that reaction, right? Now guys, let us go for this reaction. Now the point is, does this undergo intramolecular? Yes, because you have bond 2. This is first functionality, this is the second carbonyl functionality. You have 2 different set of carbonyl functionalities. Hence it is capable of undergoing, Aldol condensation reaction. So the first step is the selection of the key enolate. Both are ketones. This was our C double bond O, this is our ketone. So both are same. So you need not worry about to select whether an aldehyde or a ketone, because in here we have both ketones now. Now what is the enolate? And now can I make this as enolate and attack this? Because this is the alpha carbon which is attached to C double bond O. Is that possible? If this goes and attacks that, you are going to get this. How many membered ring? 1, 2, 3, 4. Are 4 membered rings stable? No, they are not stable. So this is not the possible stable enolate and this is not the key enolate and you have selected a wrong key enolate and probably because you have got a 4-membered ring. I told you to keep 2 things in your mind. First, aldehydes are more reactive than ketones. Let's learn back out here. I told you 5 and 6-membered rings are stable in nature. Now you see this case. Suppose if I make this as the enolate and if I abstract this proton and this attacks this carbonyl group, you are going to get 1, 2, 3, 4, 5, 6-membered rings are found to be stable. So this is what we have. Now sir, how to number this? The choice is here. There will be a bond between 1 and 6. So this is 1 because it is going to form this, and OH is formed by this 6th carbon as per that, and this is 6, this is 5, right? Or so this is the 6th carbon. In fact, this is the first. There is a bond between first and 6th. This is the second, third, fourth, fifth. You can still see it is beta hydroxy. This is alpha, this is beta. Right? So this on heating. So OH from beta carbon and H from alpha hydrogen is removed to give you alpha beta unsaturated ketone. So this is the product of this. Right? So guys, before we end our session, I would like to give you this a famous example of Nona 2,8 diol. Nonane contains 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I tell you that you have got same ketone functional group here and here. So you need not worry much about the selection of aldehyde and ketone. But you have to remember about the number of atoms that are involved in the ring. So guys, just see what are the different species. If I remove this 1, 2, 3, 4, 5, 6, 7, 8 membered rings are not preferable. So what do? I do not select this or this and going attacking. Here you are going to get 8 membered ring, which is not feasible. Now if I remove this, if I remove the hydrogen from here, if I remove the hydrogen from this carbon, the third carbon. Now if this enolate and attacks this carbon, you are going to get 1, 2, 3, 4, 5, 6 membered ring, which is stable. Now see, this carbon first donates its electron to oxygen. You have got O minus, right, which reacts with water to give this. Right, so this is what we have. Now is this beta hydroxy? Let us check it out. This was our carbonyl group. This is alpha, this is beta, and now I heat it. Right. Now, if in case if you are worried about, sir, how the numbering goes, now let us start. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So a ring would be formed between 7th and the second carbon. The second carbon is going to form OH. So this is our second. This is getting bonded to the 7th carbon. So this is our 7th carbon. Am I right? 7th carbon is this, which is bonded to 6th in the ring. 5, 4, 3 and 2. Can you see this 7th carbon is also bonded to COCH3 and second carbon is bonded to one methyl group. Clear? So just see how we number it. There is a bond formed between 2nd and 7th. Now if you heat it, if you heat this, if you heat this, so on heating this, if you heat this, okay, so you will be getting, this product here, right? Alpha beta cyclase, alpha beta unsaturated aldehyde and ketone. So guys, this was about aldehydes and ketones. Hope you have enjoyed this session with me. In the next lecture, we will discussing about carboxylic acid, one more important chapter. Right. By the way, you people have assignment containing 25 questions, all selected from the questions based on the previous year's IIT-JEE examination. So we'll have a discussion on the assignment also in the next lecture. So we will meet in the next lecture with carboxylic acid. Hope you have enjoyed in this session with me, Vamshi Krishna, Teachtiger. If you like this session, please do like and subscribe to our channel. We'll be very much waiting for your comments. Right? Thank you. Have a nice day.